In this installment, we'll take a look at position time and some insights we can get from algebra. We know our definition of displacement is x minus x0. We notice on this side over here, there is an x and an x0, but they're on different sides of the equals. So if we were to bring them to the same side by subtracting x0 from both sides, we would end up with x minus x0 is 1/2 at squared plus v naught t. And x minus x0 is delta x. So this version of the formula, this and this are exactly the same thing when we have properly substituted in for displacement, which is not necessarily obvious. You might also see in other sources on the internet for people to refer to displacement as d. Of course, that's not really sensible, but in any case, that's the relationship there. The next thing I wanted to point out is that if we solved for x, we would add x0 to both sides, giving us x equals delta x plus x0. And we may remember from a previous installment that all we need to do to find the instantaneous position is add the initial position to the displacement. The next insight we want to say is what happens when the initial position is 0? Well, when the initial position is 0, this equation becomes x equals 1/2 at squared plus v naught t. And in this case, when x equals 0, as we were just saying, when the initial position is 0, well then that becomes 0 and x equals delta x. In this next case, where the initial velocity is 0, we have x equals 1/2 at squared, 0t plus xo, and we end up with x equals 1/2 at squared plus xo. And of course, if we subtract xo from both sides, we end up with delta x equals 1/2 at squared, which by itself is a very, very useful formula. We use that very often. And if the acceleration equals 0, then we end up with x equals 1/2 0t squared plus v0t plus xo. And that then is x equals v0t plus v0, x0. v0t plus x0. And of course, subtracting xo from both sides gives us delta x then is v0t. And of course, if v0 is constant, then v0 equals v bar, and v0 then is delta x over t. Where t0 equals 0. So they're just some algebraic insights connecting some of the things we've talked about in the last few installments. Now let's take a look at some algebraic insights for velocity time. Just as displacement is x minus x0, delta v is v minus v0. And we have this equation over here which requires a to be constant, delta v equals v minus v0. So let's consider the case now where v0 equals 0. So that gives us delta v then equals v. Delta v equals v. And if v0 equals 0 on this side, then v equals at. Well, if v equals delta v and v equals at, then at equals delta v when v0 equals 0. Now, none of these things is necessary for you to remember or record all of these different formulas, and we'll see when we do a recap, there's only about 3 formulas you need to know. The intent of these videos is to show you the relationships between them. Let's look at another relationship with velocity time. Let's look at the case where v equals 0. Well, if the final velocity is 0, the instantaneous velocity is 0, then delta v equals minus v0. If v equals 0, then delta v equals v0. And by that token, if we have v equals at plus v0 and v equals 0, we will notice then that at equals minus v0 equals delta v. So in essence, what we're seeing in these equations is that this term at is equal to delta v. And lastly here, we have the equation acceleration. The average acceleration is delta v over delta t. Now we know delta v is v minus v0, and delta t is t minus t0. And we're saying here, let the time begin at time 0. So that gives us v minus v0 over t. So therefore, the average or constant acceleration equals v minus v0 over t. Multiplying those through, we end up with v minus v0 equals at. And solving for v, we add v0 to both sides, and we end up with v equals at plus v0. So what we see then is that this equation for the average acceleration, which is a slope of a vt graph, is exactly the same thing as the linear equation. And you should have learned this in your math classes, that the formulas y equals mx plus b and m equals delta y over delta x are the same formula, just rearranged. That's what we're saying here. And those are some algebraic insights into those two formulas.